Good morning. Okay, so this is Wednesday now, and obviously I'm wearing the same clothes I wore Monday because I'm taking this all this one time, so it's not a big deal. And Monday we talked about ionic bonding, when you have a metal and a non-metal coming together, and we'll show you how they stick by transferring electrons one to the other. Today we're going to talk about how non-metals stick together. Okay, you never have a metal-metal interaction, so you don't worry about that one. So this is the last of this kind of piece we have to talk about. But today we're going to talk about covalent bonding. In ionic bonding, the metal would give it up to the non-metal until everybody was happy and stable with their octet rule. For covalent bonding, it doesn't work like that. For covalent bonding, we're going to take two or more non-metals and we're going to have them just play nice and work together and do these kind of things. Okay, so what we're going to do today is covalent bonding. And what happens in covalent bonding is you do what calls sharing of electrons. Okay, of two or more non-metals. So we're only looking at things from the right side of that stair-step line. Now, remember, hydrogen's in the wrong place. Okay, remember, a lot of you guys had your drawings right perfectly, right? Hydrogen is not over here. It's not a metal. It really should be over here in the non-metal side. So we just kind of stuck it in the middle. All right, show you how that stuff works out. But these are going to share electrons of two or more non-metals. So there's not going to be any transfer. There's not going to be any charges. Okay, it's just going to be do that kind of stuff. So we're still going to use our Lewis dot diagrams, and we're still going to fulfill our octet rule. Okay, and the easiest one to talk about this for you guys to understand is for water. Okay, all of you know, I just had my arm on the table, sorry. All right, water is H2O. So how does that stick together? How does two non-metals that can't transfer each other up make this stuff work? All right, well, we're still going to use a Lewis dot diagram. So if you look for hydrogen, it's got one valence electron. You have another one, because it's H2. These little things right here are called subscripts. All right. All right. We're going to talk about that later on. Get rid of that for now. Okay. And oxygen, how many valence electrons does that have? Well, if you look on the chart, it's got 6V. And so 1, 2, 3, 4, 5, 6. Now, if this were ionic, where one thing was on the left and one thing that was on the right, these would pull and go over here and that kind of stuff, but then nothing would work out because the electronegativity of those two things, they both want to steal. All right. They both want to go get them from something else. All right. And so that's not how this works. All right. So what happens is this. These things get really, really close together. I like to say they snuggle. Okay. And this, by getting really close together, this electron sort of gets into that energy level, sort of gets into that loop, and this one sort of gets into that loop. And so what happens here is you create what's called a covalent bond. We share them. We share them. We share those pairs of electrons. So what happens is the electrons that you share, okay, count for both of them. They count for all of the atoms that you need them to count for. So right now, hydrogen has the two that it wants. It's in that first energy level and can only hold two. So hydrogen has its two. Well, this one does too. So both the hydrogens are perfectly happy. The oxygen has its 1, 2, 3, 4, 5, 6, and shares 7 and shares 8 is happy too. All right. And by snuggling and sharing and coexisting together, everything has happened. And what you do is you create what's called a covalent bond. Now, with ionic bonds, it was literally the charges that were holding them together. Remember that? Just go back and watch the video I made on Monday, before Monday. But what happens is H bonds to the O, which then also bonds to another H. And that's what water looks like. Now, you got to be careful. You're saying to yourself, well, if I'm drawing this the first time, here's what I get from a lot of kids. All right. What if we just do this? What if we just make those two things there? All right. And that happens. And this would be perfect. All right. Hydrogen has one, shares two. This hydrogen has one, shares two. But if we're talking about with oxygen here, now this is the outsider looking in, doesn't share with anything. Oxygen is now sad. All right. And so it's not happy, right? It makes a sad face. So that's not how this thing bonds. But if we're just talking about these two things together, it wouldn't be H2O, it would just be H2. And sometimes things form what are called diatomic molecules. Pairs of atoms that just bond with themselves, diatomic, two of those kind of things. And so you can have H2, O2 does this a lot, nitrogen does this a lot, And then every single stinking halogen loves it because they are all nonmetals and they are one away from being stable. And so all of the halogens do this as well. They just bond together. But well, that's for another time. But again, make sure everything's happy, right? Now, let's talk about this compound right here, H2O2. Now, you guys may not know what that is. This is hydrogen peroxide. I don't get H2O2 and water confused. Hydrogen peroxide is great for killing bacteria and things like that. Not so good to drink, so not really hard on the stomach as you guys go through this. But we're going to draw Lewis dot diagrams for all of this. The key is, the great thing about covalent bonding is I got to tell you the formula. Because without the formula, you can't just guess. I'm not having you guys do that. That's not the point. All right, so there's that. There's that. With my 6, always use our Lewis dot diagrams. Put it this way so it'll be a little easier. Okay, so what happens is this hydrogen moves in really close to this and shares and snuggles and makes it happy. This one moves in really close to this, shares and snuggles and makes that happy. Okay, this hydrogen is good. This hydrogen is good, guys. 1 shares 2, 1 shares 2, and it's in the first energy level, so it only needs 2. Oxygen has 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Neither oxygen's happy. Share 7, but neither one of these two is happy. They both want 8. So what happens is they just snuggle with themselves. And there we go. Now oxygen has 1, 2, 3, 4, 5, 6, shares 7, shares 8. 1, 2, 3, 4, 5, 6, shares 7, shares 8. That one's happy, that one's happy, that one's happy, that one's happy. Everything is happy. And the idea is that if everything is happy, we create a word, we create a chemical formula where all of our things that weren't happy are now happy. So now how does this work? All right. H to the O, to the O, to the H. There's my bonding. Every time you have a shared pair, you have a line. And that's what our bonding looks like as you guys go through this. Okay. One of my favorite ones to show you how this works. Remember, all of these are with 2 or more non-metals. So you're looking just from the things from the right of the stair-step line. One of my favorite ones is this one, HCN. H has 1 valence electron. C has 4. Again, just look at your chart. Nitrogen has 5. 2, 3, 4, 5. So we snuggle this one up next to this one, and now this hydrogen is happy. This one needs 3, so does this one. So it just snuggles up, snuggles up, snuggles up, makes everything happy. Now that one's good and that one's good. Now, if you're confused, if I'm going a little too fast for you, remember octet rule, everything wants its outer level full. So hydrogen has its 1, needs 1 more, so it shares it, so it's good. Carbon has 1, 2, 3, 4. It needs 4 more. It shares the 5th, shares the 6th, shares the 7th, shares the 8th. That one's good. Nitrogen had 1, 2, 3, 4, 5 originally, shared 6, shared 7, shared 8. That one's good too. So there's 1 bond here. So that's H to the C. Now, we're not doing this. N, 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 N. We don't have 4 single bonds to the N. What we have is 3, what are called coordinate covalent bonds. You don't need to worry about that part, but we have 3, 1, 2, 3. Every shared pair gets aligned. 1, 2, 3. We create what's called a triple bond between the C and the N. And so that's how it is. HCN is how it's all bound together. Okay. So what I want you to do is a very simple little worksheet. I want you to try this. All right. Is you're going to do this worksheet right here. Okay. It's on the back of that chemical analogies page you guys did, or you guys have in your packet with the who am I stuff and all that kind of stuff. It's in, I want you to do this page right here. You're going to do these 6 little problems. That's it. Just these 6 little problems. You don't need to do anything else, whatever. Do your drawings. If you mess them up, it's okay. But you should write out your formula, which they have written out for you. Draw your dots, draw your things, and then try to put these things together. So I'll do the first one for you. Here's F2. Okay. Okay, not trying to hurt you. It's got 7. Well, so does the other one. This little thing subscript right here tells you how many you have. How many of each one of these need? They have 7. They want 8. And that's all you have to write. There's your answer number 1. Okay, so try the rest of these. Try the other 5. All right. As you go through, that's going to be your assignment for today. And then we'll see you guys on Friday to talk about polyatomic ions. Again, stay safe, everybody.